So welcome everybody to this brief presentation on crisis mitigation and the predictive analytics. We're going to talk about our experience in measuring famine risks. I'm going first to define the framework of fragility risk and mitigation. If we frame fragility as the risk of crisis and we look at the time structure, we can distinguish between two phases. First, a silent phase, when there is a slowdown of capital accumulation. Then, an active crisis phase, when the stock of capital is depleted, leading to permanent damage. As we are assuming the following, that fragility, the risk of crisis, increases at an increasing rate, while decreases at a decreasing rate. And we now see the defining features of our fragility framework: slow onset, risk of sudden escalation, and slow recovery, with a very long plateau when risk of a new escalation remain very high. Now we also see that the compound risk can lead to a sudden escalation with non-linear jumps of probability of crisis. The theory of change then highlights that early action through crisis mitigation and prevention serve both the purpose of reducing the risk of escalation and reducing the time needed for recovery. However, crisis risks are very pervasive in the development world. How do we decide to engage in early action? Now, 3 years ago, we decided to explore the potential of predictive analytics to support early action in the specific case of preventing famine. The first thing we did was to define the problem in a way that could be modeled. Based on the widely accepted IPC scale, we defined a crisis transition tailored to support the objective of famine risks reduction. In the specific case, crisis was defined as all situation under IPC 3+, crisis, emergency, and famine. The second thing we did was to decide the modeling capabilities we wanted to develop. The scope of work covered both real-time data and probability of transition from non-crisis to crisis state. What goes into it? We looked at rapidly changing factors such as NDVI, rainfall, market prices, and conflict, and slow-moving context variables. Went into it. What were the results and what is the predictive capacity? We see here the comparison of accuracy across different types of models and 3 main takeaways of that exercise. Number 1, work shows that models can generate robust predictions of the risk of future food crisis. Number 2, complex models do not necessarily have the edge, as we see here. Random forest seems to be performing better than more complex models. Number 3, very important, in all cases, higher prediction performance also comes with a higher number of false alarms. Models do trigger quite a lot. That means that true prevention requires an upfront investment. It is now the job of a new generation of economists to show that the cost is definitely worth it. Many thanks for your attention, and feel free to contact us.